Solving rational equations and inequalities. Our objective is to solve rational equations and inequalities. Who uses this? Kayakers can use rational equations to determine how fast a river is moving. So let's start by solving this rational function. We have x plus 8 divided by x equals 6. We want to get rid of this x in the denominator. So to do so, we're going to multiply everything by x, because you can't just multiply one thing by x. It wouldn't work out. So everything is going to get multiplied by x. So your x is going to get multiplied by x, and your 6 is going to get multiplied by x. And when you simplify, you end up with x squared plus 8 equals 6x. Move your 6x over. So we have x squared minus 6x plus 8 equals 0. And now we can factor. So we want two values that when you add them, they give you, when you multiply them, they give you 8. But when you add them, you get negative 6. So we've got negative 2 and negative 4. So we want our 0 values because we're solving here. So the value of 0 for this first one, you would get 2. And for the second one is 4. So x equals 2 and x equals 4. Now let's look at extraneous solutions. Remember, an extraneous solution is a solution of an equation derived from an original equation that is not a solution of the original equation. So let's look at this first one here. We have 3x divided by x minus 3 equals 2x plus 3 divided by x minus 3. We know that you can't have x being 3 because that puts 0 as a denominator. So technically x cannot equal 3. So there's your extraneous solution. So now let's solve. We don't want these variables in our denominator. So we're going to multiply both by x minus 3. So if we take our 3x over x minus 3 and multiply that by x minus 3, and we take our 2x plus 3 over x minus 3 and multiply that by x minus 3 as well, all you end up being left with is 3x equals 2x plus 3, as these cancel each other out, or if they equate to 1. So now we solve for x. So we're going to subtract 2x from both sides, and now we end up with, hey, x equals 3. Wait a minute, we just said that x couldn't be 3. So x equals 3 is extraneous because it makes the denominator of the original equation equal to 0. Therefore, the equation has no solution. Your solution can't work. No solution. So let's try B. Looking at our denominators, we know that x cannot equal positive 7. So with that, let's solve. So we want to get rid of these denominators, and to do so, we're going to multiply everything by the denominators that are there. So our 2x minus 9 over x minus 7, we're going to multiply that by 2 and x minus 7. And then we're going to do the same thing to this next one. So we have x over 2. We're going to multiply that by 2 and x minus 7 as well. And we're going to do the same thing to our last piece. So our 5 over x minus 7 is also going to be multiplied by 2 and x minus 7. When this happens, things become a little bit simpler. So those cancel each other out, those cancel each other out, and those cancel each other out. So now we're left with 2 times 2x minus 9 plus, and we've got an x and then an x minus 7 equals 5 times 2. Let's simplify. So we have 4x minus 18 plus x squared minus 7x. So all we're doing is distributing here, and that's going to equal 10. And combine like terms and move everything off to the left-hand side, so to the side with the highest power. So we're going to have x squared minus 3x minus 28. That is negative 18 minus 10 gives you negative 28, and that equals 0. So now we can factor. So we need two numbers that when you multiply, you get negative 28, but when you add them, you're going to get negative 3. So that's going to be negative 7 and a positive 4, which means x can either equal positive 7 or x can equal negative 4. Well, we talked about earlier here that x can't equal 7. It's extraneous, it doesn't work. So all you're left with is x equals negative 4. The only solution possible. Let's try a problem-solving application. A kayaker spends an afternoon paddling on a river. She travels 3 miles upstream and 3 miles downstream in a total of 4 hours. In still water, the kayaker can travel at an average speed of 2 miles an hour. Based on this information, what is the average speed of the river's current? Is your answer reasonable? So we have our distance up and down is both 3. And then our average speed, so it's 2 minus c and then 2 plus c to deal with our 2 miles an hour here. And then we have our time is going to be 3 divided by 2 minus c and 3 divided by 2 plus c. Together, that will give us our total time. So our total time equals the time going up the stream and the time going down the stream. So we need to simplify this. We don't like having these variables in our denominator, so let's get rid of them. So we're going to multiply this first one by 2 minus c and our 2 plus c. And then we have 3 divided by 2 minus c, and that's also going to get multiplied by 2 minus c and 2 plus c, because once again, we want to get rid of those ugly denominators there. So then we have 3 over 2 plus c, and that needs to be multiplied by 2 minus c and 2 plus c. Yes, you have to multiply everything by what you're multiplying by, because you can't just multiply this one over here by 2 minus c and that one over here by 2 plus c. Everything has to be multiplied by the same thing to keep everything equal. So now we can begin to simplify. So this part on the left-hand side here, when we simplify, you're going to end up with 16 minus 4c squared. And now for this side. So we can cross out our 2 minus c there and our 2 plus c there. And we can distribute our 3. So we have 6 plus 3c plus 6 minus 3c. Well, 6 and 6 make 12. So we have 12 equals 4c squared and 16 here. In case you're wondering where the 3c and the negative 3c went, they cancel each other out. So now let's work on getting c squared by itself. So we're going to move the 16 over, so we're going to subtract 16 from both sides, leaving us with negative 4c squared equaling negative 4. So divide and then take the square root of that, and c is going to equal plus or minus 1. Well, since the current of a river can't be negative, that means it's going to be 1, so 1 mile per hour. Let's look at a work application. Jason can clean a large tank in an aquarium in about 6 hours. When Jason and Lacey work together, they can clean the tank in about 3.5 hours. About how long would it take Lacey to clean the tank if she works by herself? So using this hint here, so Jason's rate times the hours he worked, Lacey's rate times the hours worked, equals 1 completed job. So now, just like we've done in the past, we want to get rid of these denominators. So we're going to multiply each by 6h. So we're going to times this one by 6h, and we're going to multiply this one by 6h, And we're going to multiply this one by 6h. And then we simplify. So we have 3.5h plus 21 equals 6h. So therefore 21 equals 2.5h, because we're subtracting 3.5 from both sides. And now we divide by 2.5, leaving us with 8.4 hours. So it will take Lacey about 8.4 hours, or 8 hours and like 24 minutes. So now let's try solving rational inequalities algebraically. So we're going to solve the inequality 8 divided by x plus 5 is less than or equal to 4 algebraically. Check your answer for reasonability. Okay, so case 1 is if the LCD is positive, and case 2 is if the LCD is negative. So you have to deal with both. You don't have an equal sign there, so you need to work with both positive and negative. So your hint here is when it's positive here, and when it's negative, so you basically just kind of flip your signs around. And other than that, you solve the same way you would before. So we want to get rid of our denominator, so we multiply everything by that, which cancels that out. So now you're left with 8 is less than or equal to 4x plus 20. Subtract 20 from both sides. That leaves you with negative 12 is less than or equal to 4x. And then divide by 4, which leaves you with negative 3 is less than or equal to x. So now let's look at case 2. So we've got same idea. So we've got 8 is greater than or equal to 4x plus 20. Subtract 20 from both sides, and you end up with negative 12 is greater than or equal to 4x. And then we divide by 4. No, it doesn't always come out this nice. But that's step 1. Now step 2. Consider the sign of the LCD. So for this first one, we're dealing with our least common denominator, so that's this x plus 5. It's saying it's positive, so for it to be positive, it's got to be greater than 0. And then we solve, so x has to be greater than negative 5. So this is like step 2. Okay, so now let's try step 2 for the second case. So this is when your LCD is negative, which means your x plus 5 is going to be less than 0, because that's what makes it negative. And therefore x has to be less than negative 5. And now for our last step for both. We want to see which case or how it satisfies both. So the solution must satisfy both this negative 3 is less than or equal to x, and x is greater than negative 5. Well, x is greater than or equal to negative 3 satisfies both, so that's the one we go with. And then in the second part here, if we look, we've got negative 3 is greater than or equal to x, and then x is less than negative 5. So x is less than negative 5 satisfies both. And since it's a union, it's an OR. And there you have it. That's how you solve rational inequalities algebraically. And that also ends our video lesson on solving rational equations and inequalities.